Hi friends, after a long time I'm going to make a video, and in this video we have to discuss about some important differences between some quantities regarding the chapter electricity. Okay, so first question is, what is the difference between charge and mass? This is very important for you. Okay, first we know charge is important role. Charge is takes part and very important role in electromagnetism in electromagnetism, whereas mass has an important role in gravitation. This is the first point, that electric charge takes part in the electric magnetism, whereas mass takes part in gravitation. Okay, and the next is, electric charge can be positive, it can be negative, and it can be zero. That means its value becomes positive, negative, or zero, whereas mass is always positive. Remember it. Mass is always positive. Then charge is independent of velocity of the body. If a body moving with certain velocity, it doesn't depend on its velocity. The charge doesn't depend on the velocity, speed, acceleration, etc. and etc. Whereas mass has its effect, because it depends on the velocity of the body according to the special theory of the relativity. Here there is a special theory of relativity by which we can determine the mass has special effect on velocity, acceleration, and others. So mass is always dependent upon velocity. Then charge obeys the conservation principle. We know what is the conservation principle? Energy can neither created nor be destroyed. It can only transfer. It can only transfer from one form to another form. It is the conservation principle, and we know charge obey the conservation principle, whereas mass does not obey the conservation principle. Okay, this is another point. Then charge can be quantized. What is the meaning of quantized? That means if there are n number of particles having charge E, then by using quantization principle, by using quantization principle, you can know your charge is plus or minus n into E. It depends upon positive or negative, depends upon the charge of the electron. If it is negative, then we can write minus Ne. If it is positive, we can write plus Ne. Okay, then where it is only applicable in charge, but we cannot apply it in mass because it doesn't obey the conservation principle and it doesn't quantize. Okay, then the next point is that charge can exist without mass, but mass cannot exist without charge. Okay, if a body has no mass, it consists of charge, but if there is some charge, then that must have any mass. Okay, mass can exist without charge. Sorry. Charge cannot exist without mass. If a body, we can say, if a body has no mass, that cannot have any charge. If a body has mass, then we cannot say it may be charge, it may have charge, or it may not have charge. Okay, I think you can understand charge and mass clearly. Okay, if you have any doubt, you can ask me. Okay, let's move on the next question. Here, electrostatic force, gravitational force. Okay, first we know that Q is charge is represented in electrostatic, whereas mass is used in gravitation. Okay, so it may be attractive or repulsive. We know if two positive charge, that means two same signs, means they are repulsive, always repulsive in nature. If they are different charges, then they attract with each other. So electric force, that is two type of force are present, that is one attractive, whereas another is repulsive. Okay, whereas gravitational force is always attractive. That means if there is a ball and we throw it from a roof or from a top place, it attracted towards the earth, that is known as gravitational force. If there is a plant, mango tree, and mango is fall on the ground, that means earth, it always attracted towards the earth. So gravitational force is always attractive, whereas electrostatic forces may be attractive or may be repulsive. Okay, then electrostatic force depends on the medium between the two charges. If there are two charges Q1 and Q2, and it may be air medium, it may be vacuum, it may be water medium, it always depends upon the medium between the two charges. Okay, electrostatic force always depends upon the medium between two charges, whereas gravitational independent of medium, that means it doesn't depend, that where whatever that material, that medium may be. Okay, then electrostatic force, it is greater than gravitational force. Electrostatic force is always greater than gravitational force. Okay, that is then is smaller than, that also reverse. If electrostatic force is always greater than gravitational force, then gravitational force always smaller than electrostatic force. Okay, then we know the formula of electrostatic. We have to remember all the formula of electrostatic. Here F electrostatics, that means Fc is equal to 1 by 4 pi epsilon 0 Q1. That means if there are two charges, then we can write Q1 Q2 by R square. R square is the distance between the two charges. That is in SI system. But in for gravitational force, we can write force gravitation Fg, that is equal to G gravitation into m1 mass m1 m2 by r square, that is distance between them. This is the formula of gravitational force. This is the formula of electrostatic force. Then it is central force. Electrostatic force is a central force, and a gravitational force is also a central force. It is conservative force. It is also conservative force. Okay, these are the similarities. It obeys inverse square law. It also obeys inverse square law. There is electrostatic screen, there is no gravity screen. Okay, here electrostatic screen is present and here gravity screen is not present. It is a strong force, it is a weak force. These are all about your electrostatic force and gravitational force. I think you can understand it. Then next, electric field and magnetic field. So we know you didn't know about magnetic field, so I want to clear you what is magnetic field. If there is electric force experienced per unit charge, that is known as electrostatic field or electric field. If there is any magnetic force is present, that means the magnetic force Fmg per charge q is known as magnetic field. Okay, this is all about your magnetic field. So how can I compare electric field with magnetic field? So let's see. It is the modified space region in which test charge experience some force. Okay, we know if there is a and space whereas a charge plus q is present, so that modified space of region by which an electric force is experienced, we can conclude that that is the electric field. But in magnetic field, that is the modified space region which test pole represents some force. Test pole means one positive, one negative. Here positive, here negative. If a test pole is present there, then we can write that is the magnetic field. Then intensity. Here intensity of strength, that means electric field intensity. Okay, electric field intensity is given by E, that means electric field by plus Q. Sorry, it is wrong. Electric field intensity is equal to F by Q. This is F. Okay, whereas magnetic field intensity for strength is given by here magnetic field intensity, that means magnetic field is B vector is equal to E vector by M, that is mass. Okay, then we know if force the unit of force is Newton, and F is equal to E is equal to F by Q, that means Newton Coulomb inverse or Newton per Coulomb. Okay, this is the unit of electric field, whereas unit of magnetic field as in nu, that is Newton ampere inverse meter inverse. Okay, then dimension of intensity, here ml t to the power minus 3 a to the power minus 1, whereas dimension of magnetic field is m l to the power 0 t to the power minus 2 a to the power minus 1. Okay, we can determine it. I'll derive all these formulas in the next video. Okay, then it exerts force both on stationary and moving charge. Okay, it also, that means if the charge is in rest, or it moving with a path, so that is circular or linear, we can determine electric field. Okay, whereas it exerts force only moving charge, it doesn't exert force on the rest body, it only exert force on moving charge. If the charge or particle is moving with certain velocity or speed, then we can determine the magnetic field of that. I think you can understand it. Force exerted by electric field is direction independent. Okay, whereas it depend on the direction of the motion of the charge. As in electric field that may be rest, so the direction doesn't depend, but as it moving with certain velocity, so here direction matters. Next, electric field inside body doesn't exist. We know if there is a hollow body or solid body, the electric field inside this doesn't exist, whereas magnetic field inside a body exists. This is all about your electric field and magnetic field. So the next question. Here we have to determine what is conductor, semiconductor, insulator. There are three particles are present. How can I define what is conductor, what is semiconductor, and what is insulator? So let's see. Through conductor, electron can flow easily. Okay. Through conductor, if that body is a conductor, then through that body electron can move or transfer easily, that is known as conductor. If that is semiconductor, then electron can flow partially. It is very positive, it is something positive, and it is negative. Okay, this is properly positive, it may or may not, and it is properly negative. You have to consider it How can I determine or define what is conductor, semiconductor and insulator? So conductor can flow electron, and metals are the best example of conductor. Metals, what are they? Iron, silver, aluminum, gold, okay, copper. These are the best example of conductor. Whereas in semiconductor there are germanium, silicon, carbon. These are considered to be as semiconductor. And air, wood, rubber, glass, mica, anything you can see, plastic, book, pen, these are the example of insulator because that cannot flow electron. Then electrical conductivity is very high. In conductor, electrical conductivity is very high. Very high. But in semiconductor, the conductivity is in between conductor and insulator. This is very high, this is very low, and semiconductor is proceed in between them. Okay. Whereas electrical conductivity is negligible in compared to insulator. Then conductor, it consists of large number of free electrons. That means large number of free electrons are present in conductor, whereas only small or partial free electrons are present in insulator, and no free electrons present in partially free electrons are present in semiconductor, whereas no number of electrons are present in insulator. Resistance increases with increase in temperature. That means resistance is directly proportional to temperature. Resistance decreases with increase. That means in semiconductor resistance is inversely proportional to temperature, and resistance decreases with increase in temperature. So for conductor, that is directly proportional to the temperature, what? Resistance. And in insulator and semiconductor, the resistance is inversely proportional to the temperature. Then resistivity increases with increase in temperature. That means in conductor, resistivity, that is sigma, is increases with temperature, it decreases with temperature, and it also decreases with temperature. So this is all about your semiconductor, conductor and insulator. I think you can easily determine and define and compare conductor, semiconductor, insulator after seeing this video. Next, resistance, conductance. What is resistance? Here resistance is, we already knew about it. You can see my other videos through which I can determine briefly, very step by step, what is resistance and what is conductance. Okay. Now, what is resistance? It is defined as the ratio of potential difference applied across the two ends of the conductor to the current flowing through it. That means if there is a conductor is present and the electric potential difference between them is V and I current is flowing through it, then we can write resistance R is equal to potential V by current I. Easy. That is the mathematical formula. So from this we get 2 points. First the definition, next the formula. It is reciprocal of resistance. That means conductance G is equal to 1 by R resistance. Okay, that means I by B. We can write the ratio of current to the electric potential difference, that is known as conductance. This is the mathematical formula we know. Or we can write R is equal to rho L by A, where rho is equal to resistivity, and G is equal to reciprocal of that. This is A by rho L. This is conductance. Then SI unit is ohm. SI unit is ohm inverse or mho or Siemens, we can write it. Then dimension formula we can determine this, that is the opposite. So this is very easy for you. You can easily track. If we know any one of them, then we can write the reverse of that. Okay. Then next, resistivity conductivity. We know resistance, conductance, then resistivity conductivity. It is the capacity or ability of a conductor to resist the flow of current or flow of electron. That means resistivity is the capacity of the conductor to resist, that resist the flow of current. That is known as resistivity. And conductivity. Here conductivity is the capacity or ability of the conductor to conduct the current. That means it receives, it repels. Okay, it receives the current and it through the current. It is the current or capacity or ability of the conductor to conduct the current or electron through it. It is also defined as the reciprocal of resistivity. Okay. If conductance is the reciprocal of resistance, then we can write resistivity is the reciprocal of conductivity. Then mathematically we can write resistivity rho is equal to RA by L, whereas conductivity sigma is equal to 1 by rho, that is L by rho A. Okay. Then SI unit of resistivity is ohm meter, whereas SI unit of conductivity is ohm inverse meter inverse. Reciprocal. Then dimension we can see here, that is the opposite. Also known as specific resistance. Resistivity is also known as specific resistance, and conductivity is also known as specific conductance. Next, resistance and resistivity. Okay, we determine resistance, conductance, then resistivity, conductivity. So I want to skip this because you can write what is resistance and resistivity from before. We can deduce and discuss all things about the resistance and resistivity. So can you? Then next is EMF and potential difference. Okay. EMF and potential difference is SI unit is same, but what is the difference between them? We have to determine here. EMF is the potential difference across the terminal of the cell when the circuit is open. If the circuit is open, then we can write here that is EMF. Okay, if the circuit is open in nature, you have to remember this, that the circuit is open, then we can determine the EMF. Then it is the potential difference across the terminal of the cell when the circuit is closed. So from here we know EMF means open and potential difference is closed. Very easy for you. Then it is independent of the circuit resistance. That means it doesn't depends upon the circuit resistance. It doesn't depends upon the circuit resistance, whereas it depends upon the circuit resistance. Okay, potential difference depends upon the circuit resistance. Then it depends on the nature of electrodes and electrolytes. EMF depends upon the electrodes and electrolytes, whereas it doesn't depends upon the electrode and electrolytes. Okay. it is greater than potential difference. That means EMF is greater than potential difference. Whereas it is less than that. It is the cause of potential difference. It is the effect of EMF. This is very important for you. This is very small and you have to remember this. You have to memorize this. That it is the cause of potential difference and it is the effect of EMF. It maintains potential difference. It causes current to flow in the circuit. It maintains the what is the working of the EMF, that is it maintains the potential difference. Whereas what is the working of potential difference, that means it causes the current to flow in the circuit. Okay, the terms EMF is used for source of voltage and PD is the voltage between 2 points in a closed circuit. This is all about your EMF and potential difference. Then grouping of resistors and grouping of capacitors. I already discussed about what is resistance and what is capacitor. What is resistor, what is capacitor. So you have to put in the first point that what is resistor, that means the definition of resistor, and what is capacitor, that means the definition of capacitor. Then so for capacitor, that is capacitor is a device. So sorry, resistor is a device and capacitor is also a device. So here resistor is a device which opposes the flow of electron through it. We can write. This is very simple language. That resistor is a device and it opposes the flow of electrons or flow of current, we can write. Whereas capacitor is a device which stores charge. In capacitor we can store charge. It is also a device and it is also a device. Then in series grouping, net resistance increases. We know for resistor, if there are a number of or numbers of resistors are connected in series connection, then we can write R series or R net is equal to R1 plus R2 up to how many number of resistors are connected through the circuit. This is, that means in series grouping the value of resistor, that means the resistance increases. Whereas in series connection of capacitor, if there are n number of capacitors or numbers of capacitors are connected in series connection, we can write 1 by Cs is equal to 1 by C1 plus 1 by C2 plus so on. So in series connection, capacitors, the value of capacitor, that means the net capacitance decreases in series connection. Then come to the next connection. What is that? That is parallel connection. In parallel grouping, resistance decreases, that means 1 by Rp, reverse of capacitor. Okay, 1 by Rp parallel connection is equal to 1 by R1 plus 1 by R2. Then how many number of resistors are connected through that? That is parallel connection or grouping of resistors. Whereas in capacitor, Cp is equal to, the value of Cp is increase, C1 plus C2 up to whatever it may be. Okay, so we can know about the grouping of resistors and grouping of capacitors. Then in series there are n number of identical resistors or n number of identical capacitors are connected through that. So for series, Rs is equal to Nr, Cs is equal to C by N. For parallel, Cp is equal to this is sorry, listen it, this is wrong. This is given. The statement is correct, but we have to put this in parallel through this and in parallel to this. These are exchanged. So in parallel, Rp is equal to R by N, and Cp is equal to Nc. This is all about your grouping of capacitors. Then ohmic conductor and non-ohmic conductor. That conductor which obey Ohm's law, that is ohmic conductor, and that doesn't obey Ohm's law, that is non-ohmic conductor. This is very easy for you. You can determine. Here it obeys Ohm's law, that is ohmic conductor. Doesn't obey Ohm's law, that is non-ohmic conductor. Then example, iron, aluminium, silver, and good conductors of current, that is metal. Good conductors are metal. Okay, that is ohmic conductor. Vacuum tube, transistor, electrolyte, etc. These are example of non-ohmic conductor, because that doesn't obey the Ohm's law. Then if we draw potential current graph, if it is potential and it is current, then with increase in potential the current increases. So the graph is maybe a straight line that passes through the origin also. But in potential current graph of non-linear, that non-ohmic conductor, that is non-linear, that is not a straight line, because its value up and down. So it doesn't passes through the origin. Okay, next. Then conductor and dielectric, you can easily determine this. Conductor is large number of free electrons are present. There is partial number of free electrons are present in dielectric, and this is no electric field within the conductor, and there is polarization is to weaken the applied electric field within it. Then its dielectric constant is infinity, and its dielectric constant is finite. It is dielectric strength 0, and its dielectric strength is finite. There is no limit to the current to flow through it, and there is a limit to electric current to flow through it. This is all about. These are the very important differences of the chapter electricity. Okay, so please like, share, and subscribe my channel to get more videos, because if you subscribe my channel, so I can motivate towards to make more videos of all these chapters.